Alright, this problem talks about conservation of momentum. So here you have two, on a frictionless hockey air table, this puck A is moving towards puck B at a certain velocity, and A has a mass of 0.25 kilograms, B has a mass of 0.36 kilograms. And when A collides with B, once it hits B, it's going to bounce back off. So this is the initial picture. This is before, and here's after. So what happens after A hits B? B initially was motionless. So now B is going to the right at a velocity of 0.660 meters per second, and A is going to the left now. So A has bounced back off B at 0.115 meters per second. And the question asks you, what was the speed of the puck A before collision? So we have a conservation of momentum going on here, and what we know is momentum before the collision and after the collision is conserved. So remember, so the mv, so the mass of A times its velocity, that's the momentum before the collision, is equal to the mass of A now times its new velocity. But its velocity is 0.115, but it's going to the left. It's in an opposite direction than B's. So let's think of that as a negative velocity. So that's 0.115 plus the mass of B now times its velocity, which is 0.66. So if you put in the numbers for masses, we have 0.25 V naught equals 0.25 times negative 0.115 plus mass of B is 0.36 times 0.66, and if you divide both sides by 0.25, you end up with V naught being equal to 0.835 meters per second. Alright, once we find the initial velocity, there's another problem here. Is calculate the change in total kinetic energy of the system that occurs during the collision. The kinetic energy is equal to 1/2 mv squared. So let's calculate the energy before. So initially, the initial energy is just based on the speed of A and its mass. So it's going to be 1/2, so 0.25, which is its mass, over 2, and then V squared. So its initial velocity we just figured out was 0.835 squared. So if we calculate that out, we get 0.087. Let's put a few decimals because we're going to round this at the end here. 0.08715 joules. The final kinetic energy now is dependent on the speed of A and the speed of B. So they hit each other and then they bounce away from each other. And if there's no change in kinetic energy, we would call this an elastic collision, where the kinetic energy is preserved before and after. So let's see. So we have the kinetic energy of A after the collision is going to be 0.25 over 2, and then times 0.115 squared. And the kinetic energy, so we're going to add that to the kinetic energy of B, which is going to be 0.25 over 2, sorry, 0.36. Its mass is 0.36 times 0.66 squared. So we add those two, and we end up with 0.08, let's say 0.06 joules. So this is after we have 0.0806 joules, and before we have 0.08715 joules. So notice couple things here. The velocity on A was considered negative, but I didn't put it here because if you square negative, it's still positive, so I didn't bother to do that. The second thing is that we can see the kinetic energy before is greater than the kinetic energy after, so that it's a slightly inelastic collision. There's some energy lost, maybe in a deformation of the pucks, but that energy has been transformed from kinetic to some kind of energy stored in these two pucks, and the final kinetic energy is slightly less. In fact, it's like 0.007 something joules less than it was to begin with.